I'm Troy McClure. You've seen me in such fine quality educational videos as Who'd Ever Thought That Would Dissolve? And Solubility Product. Can we sell it on the constant market? Okay. Well, here we're going to be looking, this particular video, we're going to be looking at KSP when they give us the molar solubility. Okay? And in this case here, when we look at KSP, we have to realize that the KSP is equal to the concentration of our products to the nth power over the concentration of our reactants to the nth power, whichever it happens to be. Now, the thing is, in this case, they're asking us to determine the KSP of silver bromide, given that its molar solubility is 5.71 times 10 to the minus 7 moles per liter. Okay? So what in the world does that look like? Well, when we look at silver bromide, here we go, AgBr. This is it. This is silver bromide, and it is a solid. Now, the thing is, it does go back and forth, and it gives us an Ag with a plus, and it's an aqueous solution, which means, essentially, it's in a liquid solution, and plus Br minus, that is also in an aqueous solution. So that's the first thing we want to do. We want to look at the reaction and see how does it break up? How does it dissolve? And that would be an important thing because when we look at the KSP, we have to take into account what's our reactant and what's our product. The nice part about this is, for the KSP, is that when it's a solid, it doesn't really contribute anything. So guess what? We do not need to worry about the reactant. This is a yeah moment. Okay, so now we're left with the product. Okay, and they gave us our concentration right up here, our 5.71 times 10 to the minus 4 moles per liter. So what does that mean for us? Well, what that specifically means, ladies and gentlemen, is that our KSP is going to equal the concentration of Ag plus multiplied by the concentration of the Br minus. Now, notice that there's only one of each, which is kind of nice. It makes it a little bit cleaner and a little bit easier to deal with, okay? So we don't have to do any squaring or any of that. Great, fantastic. So now what we'll do is we'll go ahead and we're going to plug it in. We're going to plug in our values, our 5.71 times 10 to the minus 4 molar concentration multiplied by 5.71, times 10 to the minus 4 molar concentration again. So let's erase, plop. There, I'm going to feel a little bit better. 7.1 times 10 to the, and it's a 5. Okay? So that's what we have here, 5.7 times 10 to the minus 4. Okay, and then we're going to multiply that. And in the end, we end up getting, as our final answer, 3.26 times 10 to the minus 13th. This is it. This is what we have. This is the KSP for AgBr, sodium bromide. Now, here's the thing. Great. This is stuff that breaks down on 1-to-1. What about if it isn't a 1-to-1? So I'm going to do another one here. And in this case, it's similar to the problems that's on the worksheet, but it's not the exact same moles per liter. Okay? What's important is you get to know how to do this. So let's look at this KSP of calcium fluoride. Okay. Well, let's see. I got CaF2. That's going to be a solid, and that's going to break down into Ca with a 2 plus and 2 Fs with a minus. Now the dynamics are a little bit different. However, and this happens to be in aqueous. So we're back at that again. We're in aqueous mode. So guess what, ladies and gentlemen? Do we have to worry about the CaF2? No, we don't. That's the beauty of it. So let's make this a little bit simpler for ourselves. So basically, our KSP is going to equal, okay, we're going to have to look at Ca with a 2 plus, the concentration of it, but now we have to look at the F, though. And that is, ladies and gentlemen, the concentration of the fluorine is going to be double whatever the concentration of the calcium ion is. Okay, so that's going to be a pretty important idea. So basically what you're going to have here, you're going to have double the concentration of the fluorine. So you're going to have 2 of those concentration of the fluorine. And because it's a 2, remember that's your exponent, that's going to be squared. That's how you end up solving something like this. So what does that look like in terms of numbers? Well, if we look at it, our KSP is going to equal our Ca, which was 1.20 times 10 to the minus 4th multiplied by 2.42 times 10 to the minus 4th, and it's squared. So what in the world did we do here? We looked at the concentration of the calcium and we doubled it in here. Why? Because you've got, for every 1 calcium, you've got 2 fluorines that break apart. Think of this like a car. If you have 1 car, you have 4 tires in it. Okay, I've got 1 calcium, I've got 2 fluorines in there. It's a ratio of how the thing is fixed up. Okay, so that's how it's going to look out. Now, in the end, when we go and multiply this out, notice this is not exactly the same as the worksheet. I am showing you guys how to do it. Our KSP is going to equal 7.09 times 10 to the minus 12th. And that, ladies and gentlemen, would be our final answer on this. Okay? Let's take a look at another one. Okay? Let's look at another one here. And so here we have Ce with an IO3-4 like this. How in the world do we go and break this up? Well, I would say to you guys, one, this is a solid, and when it breaks up, it's going to break up into Ce, and that's going to be in an aqueous format. Okay, plus in this case, you're going to have 4 of these IO3s running loose out there. That is going to be aqueous as well. So that's what's going to happen. It's going to go back and forth, okay, and you're going to get Ce plus 4 IO3. I'm showing you guys this, not working through the numbers. I am showing you how the equation goes back and forth to get that equilibrium, because that's how it's going to break up. It's a ratio. Okay? So when you're trying to calculate the KSP of this, your solubility product, it's going to equal, okay, the KSP is going to equal the concentration of our Ce multiplied by 4 times the concentration of the IO3, which is going to be 4 times whatever this is. It's going to be 4 times in there. And it's going to go to the 4th power. So that's going to be a little bit, that's going to be a little bit more intense. But that's how you would do it. Okay? Well, guys, that's it for looking at KSP when you have molar solubility. I hope that will work things out for you, and I will catch you the next time.